Okay. We're gonna have to talk about a lot of vocabulary today. All right. So just bear with me. Okay. But what we're gonna do is we're gonna look at this picture and we're gonna maybe come up as a class with what these things are. So there's the circle. Okay. The first one we have is a chord. Okay. Not like a major chord, not like a minor chord, just a chord. Okay. Okay. Not everyone knows music. Okay. Look at a chord. Look at the chord. What do you think the definition of a chord is? Okay, so is it
1/4?
What is that? Is that a triangle? Is that a ray? Is that a line? Is it a
Semicircle?
don't look ahead. A segment with endpoints on the circle. Let's make observations about the picture. Cheater, cheater, pumpkin eater. Uh-huh.
Is that the same way you read books?
On. Okay, so now look at the secant. Find the secant.
It doesn't have endpoints.
Okay, it's not a segment. What is it? It is a line. A line that intersects the circle 2 times. So our secant is a line that goes through the circle 2 times. Okay, find the tangent. What is the tangent? What do you think?
A tangent makes it immediately equal to the diameter.
Okay, that is something that we will talk about later. Okay, that is true. But let's ignore everything else besides the circle and the tangent.
Look how long it is on the side.
Okay. So it's a line, right? So a secant went through the circle twice. Yeah. Okay, so a tangent intersects our circle 1 time. A secant intersects our circle 2 times. Okay, now I feel like you already know what a radius and a diameter are, right? Okay, where does the radius start? Okay, okay, so a segment, okay, with 1 endpoint at the center and 1 endpoint on the circle. In a circle, every single radius. This is true, we'll get there. All the radii are going to be the same. So no matter which radius you draw, all the radii have the same length. So 1 radius, more than 1 radii, that's the plural, kind of like cactus, cacti. Okay. Now, the diameter, yes, the diameter is 2 of the radii put together. Now, I do want to make note that the diameter is a special chord. So when you write this down, I want you to write that it's a chord that passes through the center. Okay, so we know that a chord is a segment with endpoints on our circle. Well, that's what a diameter is, except it goes through the center. Okay, it's a special chord, but it's still a segment and our endpoints are on the circle. Okay, 2 radii make 1 diameter. That's something you've known for a long time, right? I mean, that's like elementary school stuff, right? Maybe. Okay, so yeah, elementary. Okay. All right. So let's go to the next page. Okay. And by the next page, I mean the next page. Okay. So we wrote down a lot of things already. Radius, chord, diameter, secant, tangent. Okay. I want to talk about some of these other things like our point of tangency and some Clark's observation from earlier. So what I want you to do is right here, I want you to draw the best circle you can draw. Okay. This is going to be circle Q because our center is Q. So what I'm going to draw, I am going to draw a radius QT. And I'm going to draw a tangent line. Yeah. Okay. So I wanted to draw a picture because I think it makes more sense. So we're going to call T the point of tangency because T is the one point that our line M goes through. T is the one point that the line and the circle share. So we call it the point of tangency. Okay, any tangent line that we have will be perpendicular to the radius that is drawn to the point of tangency, okay? And that's something that Clark had noticed in our picture earlier, okay? So if I create a radius that goes to the point of tangency, we are gonna have a 90-degree angle, okay? It's a good thing we know a lot about right triangles because I bet that's gonna come in. So I want you to draw this picture right here. And our goal is to determine if segment ST is tangent to circle P. I wrote picture. That was better. If ST is tangent, what do we know about that triangle? If ST is tangent, what do we know about the triangle? It's a right triangle, okay? So maybe, I'm gonna put a little question mark, maybe that's a right angle. Hey, how long is the hypotenuse? Uh-uh, uh-uh,
It's 24.
uh-uh,
Oh, wait. 70.
uh-uh.
Wait, hypotenuse?
So this would be the hypotenuse, correct? So all radii are the same. So if this is 12, what's this? Also 12. So let me ask again, what is the hypotenuse? So how did I get the
Oh, 25. It's just outside.
25 was just the outside piece.
That makes just the orange bit.
Yes. Okay, so now we need to determine, is 12 squared plus 35 squared equal to 37 squared? You're just gonna ride the coattails of somebody else?
I'm trying to solve the 35.
I bet it ends in a 5. Alex, what's 35 squared?
Got it.
Okay, so does the Pythagorean theorem work? So since this is a right triangle, then yeah, ST is tangent because we know that that's a right angle. Mhm.
Yes, I was. Yes, I did. Wow. I was. Huh? I'm halfway there. I'm halfway 25.
Okay. I want to know what the radius of this circle is.
Oh, it has to be more than 30 because
So let's find it. We know that this is a right triangle, right? So we know that r squared plus 80 squared has to equal r plus 50 squared.
Oh, so it's basically our X.
Okay. So this gives us r squared plus 6,400. What's r plus 50 the quantity squared mean?
R squared plus 20.
Oh, R plus 50.
Mm-hmm.
Oh. Oh.
So when we multiply out r plus 50 times r plus 50, we get r squared plus 100r plus 2,500.
Oh, wait, this is the thing that we learned yesterday.
Okay, now what?
Because we learned it.
Now what, party people?
Wait, is it R?
Could you cancel the R squares out?
So if I minus r squared over, they cancel out, right? Well, r squared goes away. So let's maybe subtract the 2,500 over so that we have 100r equals
1,000.
Yeah, I told you. I already had that. So R equals 3.
r equals what?
Square.
How about just 39 when we divide by 100? One more zero, Alexa.
I accidentally did minus 250.
Mm,
Oh.
mm.
Wait, 39. Yeah.
Gosh, algebra and geometry, they're good friends.
Like,
No, no, no. Okay. Okay, we are going to draw two little pictures here. Tangent circles. If circles are tangent to each other, what do you think that means?
Oh, they bisect each other at one point.
Well, I wouldn't say bisect, but I would say that they're two circles that share a point. Googly eyes.
Yeah.
Has anybody heard the term concentric circles?
No.
You've seen a lot of them. No, more like a kind of like any sort of target, right? There's circles that have the same center. So there's our center that we all share in common. All right, so I want you to go to the next page. So there's lots of cool diagrams over here. This is probably where Ben found some answers for us. Okay. So you can see we have pictures of our chords and center, diameter, radius. Here's a secant, a tangent, our point of tangent C. Here we have, two circles that intersect in 2 points, two circles that intersect in 1 point, okay? And then here's our concentric circles. Now, I want to focus in on the tangent again. Our tangent can do a lot of cool things for us. So number one, we know it makes a 90-degree angle with a radius. But then another cool thing is if we have a circle and we have a point not on the circle, if we draw tangents from that common point, those tangents are going to be congruent. And this is another scenario where we're going to get some algebra. It's not really a triangle. We don't have a third side. Okay, so let's say I gave you a problem that looks like this. What would you have to do? Oh, we would have to set them equal to each other. So we would have to say, hey, 2x squared plus 2x equals 7x plus 12. Because we know that those two tangents from a common external point are going to be congruent. Solve it. Okay, we need to set it equal to 0, right? So we need to subtract over the 7x and subtract over the 12 so that we can factor. Okay, you and your elbow partner work on factoring that for me. So I'm guessing 2x and x has got to be our first ones, right? Braden, do you have it? No. So I would definitely start with 3 and 4 to get to 12, right? So if I put 3 here and 4 here, this is 3x. This is 8x. Oh. So we would need that, right? Would that do it for us? Negative 8x and 3x add up to negative 5x. Okay.
You only have to look on the. You only have to look on the outside and the inside, and then you get
To get this middle term. The last gives you the last. And the first gives you the first. Okay. So if 2x plus 3 equals 0 and x minus 4 equals 0, then we know x is negative 3/2 and a positive 4. Okay, now, when you do your homework, okay, your homework is gonna be page 5 of your packet. I want you to be really careful when you're naming the things I ask you to name. So if I ask you to name a radii, a chord, or a diameter, those better be segments, okay? But when I ask you to name like a secant or a tangent, those better be lines. So like a radius would be like the segment AB. However, if I'm naming a secant, I would have to name the line DE. Do you see the difference in how I'm naming them? Segment versus line? Okay, make sure your notation matches what it needs to. So it will be very important for you to check your answers to make sure that your notation matches mine. Does that make sense? Okay. Okay, so like the first half of that page is naming the vocabulary. The second half is algebra applied to your geometric concepts. Okay,